Hello everyone. In this video we will cover our functional groups. Now functional groups are sort of common arrangements of atoms you'll find within molecules. For example, if we look at the structure sheet in your here, whenever you look at a compound you want to have terminology to sort of assess the structure and structural components. And for example, when I look at naproxen here, I see here that this group here, which is called a functional group, and this functional group is a carboxylic acid. And then I see another kind of obvious functional group over here. And I say obvious because often ones that contain your heteroatoms, that is non-carbon, oxygen, nitrogen, very typical. But I see this over here, and as we will learn and see, this is called an ether. And then the naproxen also has two aromatic, let's say, rings, okay? And I'm listing functional groups here. I'm describing the structural features of the compound. And so if we're going to talk about compounds, you need to know your different functional groups. This is sort of analogous to describing the human anatomy. You know, a human has a head, a neck, arms, legs, feet. And so we have terms to describe the anatomy of the human body. That's sort of what functional groups are. And I'll use this sheet to come back and do some practice along the way. Here's the functional group handout. Okay. Now this is actually from an older edition of your Smith textbook. I like this handout because they're in this sort of table format. I think it's nicely organized. And the current edition of your Smith textbook doesn't seem to have such a table. So hopefully it's some organization for you. Now the first table here of the three, okay, there's also one on the back here. These are just your hydrocarbons, okay? Always make sure you look at the heading of your tables, what we're covering here. And let's start with the first one here, an alkane. Now, hopefully you're seeing some of these in your lecture course. Now your alkane is just your simple plain hydrocarbon with no double bonds or triple bonds. Because if it had a double bond, it would be an alkene, or triple bond an alkyne. So an alkane, an example would be just a two-carbon alkane, and that would be ethane. It's shown as a generic structure. It's really overly simplified. Alkane, ultimately, we'll say, is just sort of often just considered the backbone of an organic compound. Okay? But we can call just simple compounds such as butane, okay? I mean, all this is just it's all just alkane. There's nothing else there. There are no other functional groups there, really. Now, we can also call this a saturated hydrocarbon. All right. Now, it is a hydrocarbon because it's all just carbon and hydrogens, and we're looking at hydrocarbons. But it's also saturated. And when we cover degrees of unsaturation, you'll see what that term means. But we'll just state this for now. Okay. Now, there's really nothing listed over here. One term I can add here is alkyl. Okay. I think it's useful to add it there, and it goes along with what's listed sort of along here. Let me also add when it's a substituent. Okay? For example, if we had this ring here, which we'll see is called a benzene ring, if we had this group coming off of it, and we say, okay, what type of functional group is here? Well, that's just nothing but alkane. But since it's a part of a larger compound, it's a substituent of this ring, instead of calling it alkane, we can call it a alkyl group. Okay? So it's just kind of different terminology. When we put the YL ending on it, and we'll do that a good bit, this is when it's going to be usually groups. Okay? When it says substituent or group, because I will often use that word there, I'll say like, hey, you got the hydroxyl group. And they actually start using group, I see that down here, they actually start using that down there. Okay, so it's an alkane, just plain saturated hydrocarbon, and an alkyl group when it's part of something bigger. All right. Now, carbon-carbon double bond. This is called an alkene, spelled with an E there. All right. And so that becomes more of a functional group. I said that alkane is kind of just backbone. An alkene becomes more of a specific functional group. Pretty straightforward. I'm not really going to give you a term over here because it's not as common. There are some used, but I don't want to give more than is necessary early on here. So we'll go there. Now, if you have a carbon-carbon triple bond, those are called alkynes with a Y-N-E on the end there. And again, no group name given here. So if we come over here and I give you just a hypothetical compound and something like how about this? All hydrocarbon. All there is hydrogen and carbon. What do we have here? I see an alkene, right? And I see an alkyne. Carbon-carbon double bond, carbon-carbon triple bond. Yes, we can call this alkyl. It is alkane group, but again, that's just often just backbone and sometimes not identified. So those are pretty straightforward. Your benzene ring, it is a hydrocarbon because it's just hydrogen and carbon. The benzene ring is very common type of ring. It is an aromatic, okay? An aromatic ring. You'll learn more about that a little bit as you go along, and I think you'll probably officially cover aromatic compounds in organic too. For now, I'll give you a working definition. For a ring to be aromatic, all atoms in the ring must have a p orbital. I just said have a p orbital. We can add must have if that's not clear. All right. And once you learn hybridization, or if you know hybridization, you know in benzene each carbon does have a p orbital, so it meets this sort of introductory definition of an aromatic compound. There are actually many types of aromatic compounds. A lot of them contain heteroatoms. For example, and you do not need to know this, but just to give you an example, this is an NH. This is called a pyrrole. Okay. And it is aromatic. Okay. And the AR can be an abbreviation for aromatic. And if you look at the drug Lipitor, actually Lipitor may be on our drug sheet. It is. Okay. You see this ring here? That's a parole ring. Instead of an H, it's got an alkyl group coming off of it, and then the alkyl group contains some other groups. All right. But Lipitor also has 3 benzene rings, okay? And actually all 4 of those rings are aromatic. All right. So you don't need to know parole, but you do need to know benzene because it's so common. It's kind of the granddaddy of aromatic compounds. Now, when it's a substituent, it's called a phenyl group. And very often you would say, you know, coming off the parole ring is this phenyl. It's kind of an alternative name instead of saying it's a benzene ring. And an abbreviation for phenyl is pH. Okay, so those are the hydrocarbons you need to know there. The next table here is compounds containing, this is a little bit odd to me, Z basically Z here is a heteroatom, something other than carbon. And the first one will be when we have a halogen. Now halogen is often designated with an X. And you should know that halogen is group 7 in your periodic table. All right. I gave you a periodic table at no charge. And here's your group 7 over here. Your halogens being fluorine, chlorine, bromine, and iodine. And acetine is very uncommon. You'll never see it. But you will see the other 4. Okay. Now, if we stick a halogen on our alkyl group, it becomes an alkyl halide. All right. So here is just an alkane. Let's add maybe a bromine here. Okay. And so now, all right, or if you want to redraw that, maybe, you know, I don't want to mess up if you're keeping notes here. If we redraw that and stick a bromine on it, this is now an alkyl bromide. All right. It's an alkane with a bromide. Now we got to be careful with this "ide" ending, and I'll mention that a little bit later. But you can have alkyl bromides, alkyl chlorides, etc. It can be any of the 4 common halogens. Okay. In the example here, they just show methyl bromide. Because the R group, what is R? There's no R in the periodic table. R is generic for typically a carbon group. Now in alkyl halides, the carbon group is alkyl. All right. Now if the carbon group is an aromatic, you know, like I showed here, if we go back to a benzene and stick on maybe a fluorine, this would be an aryl halide. Okay. Now we didn't say aryl up here. Sometimes instead of aromatic, we can also say aryl. There's kind of different variations of these words here. The YL ending, okay. This would be an aryl halide. Specifically, this is an aryl fluoride. All right. Where here the R group is this aromatic ring, the carbon group, okay, that's attached to the fluorine. Oh, I had one here. There's an aryl chloride, okay. All right. Next, oxygen. Now, halogen only makes 1 bond. It's just like hydrogen, okay? So it can only have 1 R group. You should know your standard bonding. For halogen, it's, if we need to do a quick review there, because I like to give you some review along the way. You know, standard bonding for carbon, right? 4 bonds, no lone pairs, all right? Standard bonding for nitrogen, we're going across the periodic table. 3 bonds, 1 lone pair. What's up with my paper? Okay. Oxygen, standard bonding, 2 bonds, 2 lone pairs. And then your halogens, the one beside oxygen is fluorine. That's 1 bond, 3 lone pairs. Okay? So you should know that. Now often we don't show lone pairs. There they're shown, but in the structure I drew, I did not show the lone pairs. You know, some instructors, you know, a little bit different or whatnot. If you're ever asked to show a formal Lewis structure, you need to show all valence electrons, and thus then you would need to show all lone pairs. But very often they're omitted. Okay, so halogen only makes 1 bond, but oxygen makes 2. Now we have 1 R group there, so you got to have something else. If the other thing is an H, and so ultimately this is an R group with an OH, this is your alcohols. All right? And the example given here is methanol. Everybody's pretty familiar with the 2-carbon alcohol, which is called ethanol. Okay? Because your 2-carbon fragment is ethyl. Okay? And then there's different names, ways to name things, but ethanol is actually, you know, when you talk about alcohol, alcoholic drinks, that's ethanol. It's an alcohol because it's got the OH. And that's methanol. And the OH is often called a hydroxy group. Now, a lot of times you will hear an L added to these. Okay? And so lots of times it'll be a hydroxyl group. Like the phenol, it's already there, and you don't see that any other way. But I usually put the L on the ends, especially with hydroxyl. Okay. You don't want to call it a hydroxide. Okay. Hydroxide is the anion. Okay. Like this, like sodium hydroxide, because that's the anion. This is not an anion. That's a neutral OH. Okay. The problem is where you get kind of misled is up here we call this a alkyl halide and we put the IDE ending on it, which I don't like, but that's just common practice. Okay. All right. Next functional group. Now, if the oxygen has R groups on both sides, both the substituents are R groups. That is an ether. All right. Now remember, up here there was only 1 R group on the oxygen. The other side was an H. R group on both sides of an oxygen, ether. Well, let's give an example there. And we can also look at drug sheet. Let's go back and we can just say, what if we just put, you know, this here? Well, I drew an ether, okay? That compound is an ether, or we can say the functional group that's in that compound is an ether, either way you want to say it. If we draw an aromatic, we could maybe have something like that coming off. And so we can say coming off the aromatic ring is this ether group. The oxygen has 2 R groups. Now 1 R group is an alkyl and 1 R group is an aryl or aromatic. That's okay. Look at our drug sheet. Do we see any ethers on the page? And I would point to, how about Paxil? I actually see, actually, this is actually not an ether. This is a functional group we're not going to cover. It's more advanced. You may see that in organic 2. You probably will see that in organic 2, but we're not going to see it in organic 1. But this over here is a very classical ether right here. Oxygen is bonded to 2 R groups. We also have this aryl fluoride. All right, we have this aromatic ring here. We'll come back to that. Prozac has an ether. You see it? And there may be other ethers on the page. Okay. Now, the ether group, when it's a group, just the OR fragment is called an alkoxy group. Or sometimes alkoxyl, okay? Put the L on these. All right. If we go back over here, okay, we can say that this is an alkoxyl group on the benzene ring. You know, we could call it an ether group. It's also called an alkoxyl. Now the alkyl can get specific, and so if we have the benzene ring with, well, let's just use the one we already have. More specifically, since this group has 2 carbons, we can call it an ethoxy ethoxy group, because now we're indicating how many carbons are part of the generic alkoxy term. All right? And it's very common to see, just like an OCH3, and that would be a methoxy. We're just indicating the sort of the alkyl group that's on the oxygen. Okay? Now, let me just call that aromatic so I don't have to keep drawing that. But coming off the aromatic ring, if it was just OH, that is a hydroxy. And hopefully you see the reason that's a hydroxy is because what's on the oxygen, it's a hydrogen. But here there's a methyl on the oxygen, so it's called a methoxy. And generically, since a methyl is an alkyl, a more generic term is an alkoxy. I think a lot of times I don't use the L here. You know, it's tomato, tomato. Okay, so that's sort of explaining the group here. Okay, nitrogen. All right, we got nitrogens with an R group. These are called amines. Now, with your nitrogen functional groups, when you add more R groups, the name doesn't change. See up here, when we added a second R group, the name changed from alcohol to ether. With amines, it does not. Instead, what we use is we use primary, secondary, or tertiary to indicate how many R groups are on the amine. Now, this is an amine. It's a plain saturated nitrogen with an R group. Okay, there's no double bond here. Okay, keep that in mind. We'll sort of state that later. These are all single bonds. Okay. Nitrogen single bonded. Now you also have to know that that nitrogen is really bonded to that carbon. You got to be careful. And sometimes I would recommend we draw that instead sort of put the H's on the outside, okay? Now, once you get more experience with organic, you'll see that little shortcuts are done like this. But at the outset, this type of thing could potentially confuse and be like, is that nitrogen bonded to that H? Well, no, H only makes one bond. Okay, well, this is an amine. Well, what type is it, or what's the substitution type? This is a primary amine, because the nitrogen is only bonded to one R group, or one carbon. Now the NH2 specifically is called an amino group, okay? Amino. We don't call it, there's no Y or YL here, it's an amino group. Now, let's see if we have any amines in our drug sheet. Okay. Now that's not an amine, okay? We'll see later because it's got a carbonyl. Those are not amines. These are also probably, we don't want to call these amines either because they're double bonded and they're in rings. That takes a bigger discussion. Let's find a more simple amine that's just single bonded to R groups, and I see one right here. Plavix has an amine. And is it primary, secondary, or tertiary? And the answer is, since it's bonded to 3 carbons, it's a tertiary amine. All right. Now, if we look at Prozac, I see an amine here. Of course, there's a lone pair there, right? If you want to draw in your lone pairs, this is an amine. And what type of amine is that? And what I mean by that is, what's the substitution pattern? It's bonded to 2 carbons, so it's a secondary amine. Now, quick question. How many H's does a secondary amine have? Well, it has 1, because the other 2 are carbons. And how many H's are on a tertiary amine? Well, if you know what a tertiary amine is, you can, if you don't already know the answer, you can maybe draw one out and say, well, there's none there. A tertiary amine doesn't have any NH's. Okay, but a primary amine has 2 NH's. All right. Okay, sulfur. Now these 2 sulfur are going to be analogous to your alcohols and ethers. Okay, where's sulfur at in the periodic table? It's right below oxygen, so it has identical bonding. All right. Now, sulfur can do some specialized bonding because it has d orbitals, but it can also do typical bonding just like oxygen. And that's what it's doing here. So instead of a ROH, if it's RSH, that's a thiol. All right? It's a thiol shown here, where just 1 carbon. Our group is 1 carbon. Now the SH group is often called a mercapto group. You often hear it called a thiol group. That's kind of an older term. You don't seem to hear it as much often. Sometimes you'll hear put an AN on that, called a mercaptan. Sometimes a thiol, instead of a thiol, it can be called a mercaptan. Sometimes you might hear that. Let's just stick with thiol, okay, if you like, and the mercapto group. Now, when you get to biochemistry, you'll see more and more sulfur-containing compounds, like your amino acids. like cysteine. Okay, they contain thiol groups or mercapto groups. So it's sort of analogous to your alcohols, but with the SH. Okay. Now, if you've got a sulfur with R groups on both sides, it's called a sulfide. All right. And that is analogous to an ether, which has an oxygen with R groups on both sides. And because it's analogous, sometimes you will hear sulfides called thioethers. Okay, or a thioether. And thio is I think it comes from Latin. Ultimately, it means sulfur. If you look over here, I think, yeah, Plavix has this ring here. That's called a thiophene ring. And when you hear the thio, you hear that it's a ring with sulfur. Okay. All right. Alkyl thio would be the group. Probably not that common. Probably, that's getting fairly miscellaneous at this point. The ones above are way much more common, but hopefully that makes sense, okay? If you just look at it, you got an alkyl group, and the thio means sulfur. It's an alkyl group on sulfur type of thing. Okay. I was going to see if there was a sulfide over here. And actually, I do see one right here. Yeah. Do you see the sulfide in singular? Yeah. Singular has a sulfide. It has an alcohol group, or we could call it a hydroxyl group. There's an aryl chloride. We'll see this on the next page. We can come back to it. Okay. Over here we have compounds that contain a carbonyl group. Your carbonyl is your C double bond O. It's actually drawn sideways here. Very common if you're going to show a simple, you often will see the carbonyl drawn, C double bond drawn upwards, okay, as shown like here. But we can draw it sideways. Okay. So all these have a carbonyl. And we see it here. Now the oxygen makes two bonds, two lone pairs, so the oxygen is not going to have anything else on it. We want to look at the carbon of the carbonyl group. Okay? And what is on that carbon? If there's an R group on one side and H on the other, that is an aldehyde. All right, here's a specific example with the R group being methyl. Now, that's the carbonyl group. I don't like, carbonyl is, to me, not a functional group. Carbonyl is a component of different functional groups. The functional group here is your aldehyde. So I don't agree with this. I don't like this. And if I ever ask you for a functional group, I'll hear this is an aldehyde, okay? Because all these contain carbonyls. So if you start calling it carbonyl, then you're like, well, what exactly is it? If it's got an R group on one side, H on the other, it's an aldehyde. If the carbonyl has R group on both sides, is called a ketone. And here is where both our groups are methyl, and that's actually acetone. That's a common name, but acetone is fairly common in the drugstore because it's, when you buy fingernail polish remover, it's often acetone. If you look on the, if you got a bottle of that around, look on the bottle. Or it could be ethyl acetate, which is something else. It's actually an ester. Okay, I forgot to mention up here. Sometimes when you see some functional groups, they're shown sort of condensed. Not a full structure, but there's some information here. And the condensed version of the aldehyde head group here, we can call it, is CHO. And this sort of arose because a lot of times if you're just typing and you want to kind of indicate an aldehyde, but you can't draw a structure, you can just type something like CH3CHO, and hoping that everybody knows that this here is really that structure. It's the methyl group, and then you got the aldehyde head group or terminal group. Okay? So I want you to know that because it's super common. All right. Now, next, if you got a carbonyl with R group on one side and OH on the other, okay, not H, but OH, these are your carboxylic acids. And you've likely heard of these, okay? In Gen Chem, no doubt mentioned at some point, acetic acid, which that right there is acetic acid. And so that's a carboxylic acid. And if we come back over here, or before we go back over there, this head group here is called a carboxy group. Okay? Now, it is also often condensed. And it is often condensed to either COOH, because that's what you have here. You got a C and you got two O's and an H. Remember, when you do this, we're just kind of like typing, so we can't show structure. But since there's two H's there, you may also see it CO2H. All right? And so for acetic acid, sometimes you may see it drawn as CH3CO2H. All right? Or typed out that way. Or again, OO. You call it carboxy group. Here again is where I tend to put an L on it, and many chemists do. You'll hear carboxyl. Or sometimes carboxyl, if you want to kind of stress the ending a little bit more. Okay. And if we come back over here, if we look at singular, what do you see right here? What functional group? That's actually a carboxylic acid. Okay. Now, I abbreviated this. In a testing format, you would want to spell that out and spell it correctly. Okay. But the carboxyl group is shown condensed here. You need to be able to recognize that. Very common. All right. Now, if we pick up from the acid, the carboxylic acid, and a lot of times these are just called acids. Okay, particularly if you know you're dealing with a carboxylic acid, you say, "Hey, look at the acid here." Okay. Now, if we refer to the acid, but if we put an R group on the acid, and so we got an R group on one side and OR now on the other, we now have an ester. Okay? This is kind of analogous to when we add another R group to alcohols, it becomes ethers. But if we add another R group, or if we add an R group to the oxygen of the acid, it becomes an ester. Okay? And we got this ester shown here. Now this is actually a methyl ester. And I tell you that because hopefully that makes a lot of sense, because what group did we add to the oxygen? We added a methyl group. And so that is often called a methyl ester. And if you added an ethyl group, that would be an ethyl ester. All right? Okay, let's move to a carbonyl bonded to a nitrogen. All right? All these have R groups on one side. You see that consistent? All right? We're really looking at what's on the what else is on there, what's on the other side. The other side is nitrogen. This is called an amide. Now, amide can be pronounced like that, or some people will say amide, or some people will say amide. I say amide. Now, the long version of this name is carboxamide. And when I say carboxamide, I reckon I say amide on the end there, where when I just say here, I say amide. You could say carboxamide, but that's a long term that sometimes you may see. Amide is actually sort of an abbreviated word from here. But the carbox comes from the fact that it's got the carbonyl group. Okay? Now, it really doesn't explain why the X is there. Okay? Can't really explain that, but that's just what they're called. Carboxamides, or for short, you can just call it an amide or amide. Okay. Now, just to kind of tell you why carboxamide is sometimes used, because you could have, instead of a carbonyl, if you had an SO2 group, okay? So what I've done here is I've removed the carbonyl and put a SO2, okay? All right, RSO2NH2. This is called a sulfonamide. Now, you don't need to know this functional group, okay? But actually, you know, Levitra has a sulfonamide here. Now, this one, we never shorten it to just amide, all right? We only shorten it to amide when it's a carboxamide, when it has the carbonyl, all right? But that's just to tell you that there are other types of amides, and I don't know if there's a third type. There may be, but these are the two most common. That's the one to kind of tell you about. Okay. Now with amides, just like amines, if we put more R groups on the nitrogen, we don't change the name. We just indicate how many total carbon groups is the nitrogen bonded to. All right? So, if we have this right here, well, it's an amide, okay, or amide, but it is a primary amide because the nitrogen is only bonded to one carbon. Now, if we put well, let me give you another. Instead of just like this, let me draw you something a little more complex. How about a ring? And let's put a carbonyl, and let's put an H here. Is that an amide? And the answer is yes. Really, the amide is right here. Okay? Yes, the nitrogen does come back and attach to the carbonyl, but we have a carbonyl, okay? And on one side is just an R group, it's just a carbon, and on the other side is your nitrogen, okay? An R group on one side, nitrogen on the other. So don't let the fact that we're getting a little bit more complex throw you here. That's an amide. Now, is it primary, secondary, or tertiary? Well, how many carbons is the nitrogen attached to? It's attached to 2. This is a secondary amide. All right. Now, if we look at our drug structure, come back here, and early on I told you this is not an amine. If the nitrogen's bonded to a carbonyl, it's not an amine, but that's an amide. The other side is just plain R group. Here we have a tertiary amide. Yeah? And what do we have here? By the way, you can pause your video at any time. That's one of the benefits of having a video. Pause it, take a break, regroup, answer a question. But right here, what do we have? That is a secondary amide. You know, the whole thing here. Okay. Next, acid chlorides. This is where, of course, R group on one side. The other side is a chlorine. All right. Now, why are we doing specifically just chlorine? Because over here we had all 4 halogens possible. With these guys, you typically only see the chlorine version because these are very reactive. Okay? You're not going to ever find these in nature. These are made in the lab, and typically we always just make the chlorine version. So that's why it's very specific. Also, it says acid chloride. A lot of times you will hear these called an acyl chloride. That's because your R group is called alkyl, but an R group with a carbonyl is called an acyl. Now, you don't have to know this here for me. You will learn this in organic too. When you look more specifically at your carbonyl-containing functional groups and their reactivity, or we can say their functional nature, okay, how they behave, and that's why they're called functional groups. Because each functional group sort of has its own unique chemistry that we ultimately learn, and that's a big part of organic chemistry. Okay, but I'm just telling you this so you'll have it in your notes, because that term is very common. That's actually a more official name, and an acid chloride is more slang. It's called an acid chloride because these are always made directly from your carboxylic acid, and they can be converted easily back to the carboxylic acid, so they have a key relationship to the acid. Okay. There's some other condensed here. You don't have to learn these. The ones I mention are the ones I want you to learn because they're just so much more common. Okay. And remember, carbonyl is not an exact functional group. All right. Okay. There are 2 additional ones you need to know that are actually not on this list. and they both contain nitrogen. And one of them is with a triple bond, okay? If we remember, we had carbon-carbon triple bond is called an alkyne. If you have a carbon-nitrogen triple bond, that's called a nitrile. Okay? Now, of course, typical bonding for nitrogen, 3 bonds, 1 lone pair. I showed you a full structure here. There's nothing else on this nitrogen because it's triple bonded. And the carbon only has 1 other group because it has 3 bonds to the nitrogen. Now, these are very routinely shown just condensed, just CN. Okay? Now, this CN group is very commonly called a cyano group. All right? And so if we look at our drug sheet, if you look at the bottom left, do you see a cyano group? All right. Yeah. And it's shown condensed. Very often, well, why didn't we say nitrile? These are often not used unless the compound is fairly simple, okay? If I just gave you something like this, that's just a simple nitrile compound. But once we start adding other functional groups, maybe we got this alcohol group or hydroxyl group and the ketone, it's no longer really a nitrile. And actually, when you get to advanced naming, you have to determine which of these takes priority and how do we want to call this a nitrile? Do we want to call it an alcohol, or do we want to call it a ketone? Okay? And so very often we'll just say, hey, you got this carbonyl group, okay? Or the hydroxyl group, or the cyano group. But this is probably going to be classified as a ketone, okay? But you don't need to know any of that. I'm just telling you that that's why I just sort of went with calling this a cyano group instead of calling it a nitrile. But they're often interchangeable, and it just takes time for you to kind of learn the lingo, and different chemists use the lingo differently. Okay, last one, your nitro group. Okay, good thing about the nitro group, there's no name. It's just called nitro group. Here, the nitrogen, it's bonded to 2 oxygens, and you got 2 charges. And it's routinely just shown condensed. Okay? But I would ask you that you do know Lewis structure for your nitro group. Now, you'll probably officially cover them in organic 2. That oxygen is a standard oxygen, 2 bonds, 2 lone pairs. But these 2 are not standard bonding, and so we expect charge, and indeed they do have charge. And hopefully you can determine charge, and you can see why that's a negative and that's a positive. Now, of course, when we show a full Lewis structure, we need to show charges. The net charge of your nitro group is neutral. Okay? So it's net neutral. But that's a nitro group. You don't often see nitro groups in drugs. I mean, you do, but they're not as common as like amides or amines. And actually, I don't think there's a nitro on this page. Nitro groups are big in synthesis. You'll see those along the way. Okay, there's nitro. How can we end here with functional groups? You want to do another for practice? Let's see. Well, what's the rest of the functional groups in verapamil? Okay, you can pause the video. All right, we can pick back up, and I see this tertiary amine. And then I see these two ethers here. I put plural, or ether. You got two ethers. Let me ask you this. Specifically, what type of ethers are these? Okay, these are both methyl ethers. Because that's just the simple R group that's on there. All right. You can try some of the others for practice, but they're your functional groups. When we do IR, we'll be talking about functional groups, and we'll be looking at the different peaks for different functional groups. And if you don't know what a functional group is, you're going to have a tough time there once we start using the lingo. Okay, I think that finishes up our functional group lecture here by video.